bridge. Can you hear us? Hello, Alex. Hey, Liz. Okay. That sound from Vietnam. California. Nice, nice. Ohio. MD.
Cool.
Kentucky, Delaware, California. Well, looks like we've got a lot of people in here tonight. That's great to see. Yes. Oh, Philadelphia. Got from there. That's nice. Why is there an echo? Okay, looks like more person from New York. Somewhere on the planet. Me too, Hugo. Me too. California. California is great. Oh, there's a lot of echo. That's unfortunate. We are working on that right now. Okay, I can keep reading stuff off, but there might be a bit of an echo. Yeah, looks like we got some more responses, which is great. Keep it coming. Seems like you guys all know how to use chat relay, which is amazing. Okay, yes. Hello, JL. Yes, as was put in chat, we would love for all you guys to send your messages in through chat relay. It just makes it a bit easier for you guys to hear us clearly and for you guys to communicate with us because this is our best way of hearing you. Yes, hello all of you once again. What's up? Not much. What about you? Oregon is a great state, so I've been told. Yes. Me and Kieran are both from Nevada, I believe. Yeah. So we can gamble.
Yes.
You can't. Take that. Death Valley. It's not displaying. What's not displaying? California is great. Illinois. Awesome. Yes. Hello. Welcome you all. What's good, chat? Ah, yes. Okay. So we will probably get kicked off in just a minute. So I think we might have a quick introduction from our Math Kangaroo host of the day, and then we'll get into what you guys all came here for, which is the actual mathematics. So Noah, you want to introduce us?
All right. So today we have Megan. Megan enjoys participating in math competitions, both locally and nationally. She represented Nevada at Math Counts Nationals and has qualified for Math Prize for Girls. She is also the president of her school's math club and is active in her local math club, including being on the competition team and volunteering over 100 hours per year. She also plays the violin and speaks Spanish. And also with us today, we have Kieran. Did I pronounce that correctly?
Kieran.
Kieran. Okay, got it. Kieran, who qualified for Math Counts National 3 times, and he has served as the coach for the Utah Math Counts national team in 2022. And he has also qualified for the USAJMO since 8th grade. And apart from math, he is a tennis state champion and he loves to run.
Yeah, so thank you for those great introductions. So basically the structure of today is that we have some other people on our team have picked out some questions from the grade 9 through 12 Math Kangaroo question set. We have not yet looked at them, but so we're just going to solve them live here in front of you. You guys are free to give whatever you think about the questions in here, answers, suggestions for us, all of that. And without any further ado, unless you guys have any questions, I think we can get started with the first problem of the day. And so that is going to be up on my screen right now, and it says an equilateral triangle of side 12 has the same perimeter as a square of side x. What is the value of x? And of course, to solve this, we are going to find the perimeter of both of them. So the perimeter of our equilateral triangle, since it's equilateral, all sides have length 12, so 3 times 12. And we know this is the perimeter of our square of side x. Now, the perimeter of a square is 4 times the side length, so 4x. And then we just do some division. 36 over 4 equals 9, so that is x. And like you guys have been saying, that is option A. So yeah, great job. I think Kieran's got a nice diagram for us.
Yeah. It's what Megan was saying in diagrams, I guess. Yes.
Awesome.
All right. Yep. Okay. All right. Let's go on to number 2 here, which is number 5 on the test, I guess. So a square of numbers is taken out from a multiplication table. Only one number. The integers x and y are positive, and x is greater than y. What is the value of x? Hold on. So I'm not sure. Again, what does this question mean? So, like, I know a multiplication table is going to look like something like this, right? Where we're going to have numbers along the top row, along the top row right here. So like, let's say like 3 down here. And then we've got 1, 2, 3, and then 2, 2, 4, 6. And then what is 6? And then what is it? 3, 6. So it says a square of numbers is taken out from a multiplication table. So does this mean a multiplication table? So does this mean like, what does that mean?
Huh. Okay. Only one number is visible. The integers x and y are both positive and x is greater than y. Huh. I think, are we looking at a wrong version of the question? Huh.
Yeah, I don't really understand it because I don't understand where x and y come into this question, right?
Yeah. That is confusing. Does anyone in chat have an idea? Or maybe are we looking at the wrong version of the question? Oh, have images. That's probably it. Yeah.
Let's see, does the next slide have a picture?
Okay,
No,
yeah.
it does not.
Unfortunately, we were not given the image. Oh, okay.
That makes a lot more
There's an image
sense.
that we're missing. That's unfortunate. Great to see that you guys know the answer, though. So, Kieran, you want to try the next question then, maybe?
Yeah, sure. All right. We have an image this time, though. So that's good. Smartphone. This diagram shows how much time she spent last week on each of her apps. This week, she half the time spending on 2 of the apps, but had the same amount of time on the other 2 of the apps. Okay. So I'm gonna try to translate our picture here into words, into numbers. And so representing how long each of these bars are. And it's a little bit faint, but you can kind of see that on each of these 4 things that I've put here. And so it's equally spaced. And so through all 4 gaps, kind of. And then the second one goes through 2 of the gaps. The third one goes through 2 of the gaps, and then the last one goes through 1 of the gaps. And so I'm just gonna look at all the answers and see which one lines up with having 2 of them the same. So first with number 1, I see the first bar is at 2. The second bar is the third bar is at 1, and then the last bar, it looks like it's halfway, but between. So this one would be 1/2. And answer choice A doesn't look right here because what I'm doing is I'm having all of them, right? We had 1 and now we've got 2, 1, 1, 1/2. So that's having all of them. So it doesn't seem right. So now B. So the first bar for B is the full length, it's 4. The second one is 2. The third one is 1, and then the last 1. And what I'm doing for B, I'm keeping 3 of them the same, right? Because this is 4, 2, 1. Those are all the same as 4, 2, 1. Those are all the same as this 4, 2, 1, except this, the third row. And so that one doesn't make sense because we're only having 1 of them instead of having 2 of them. So B doesn't seem right. All right, what about C? So the first bar has length 2. First bar has length 2. Second bar is length 2. And this one looks more correct. I see a lot of people saying C and a lot of people saying C in the chat. So I think I agree with this because the first bar is big, and then this third bar is being halved from 2 to 1. The other 2 are unchanged. So, and I guess for completeness, we can look at D and E, and you would also find that, like, for some reason, those would not.
Yeah. One of the beauties of Math Kangaroo is that because it's multiple choice with questions like this, you can not only find the right answer, but check that all of the others are wrong, and then you can be doubly sure. And yeah, it's definitely not like super popping off the page as to how to know whether or not something is possible. What might help is to look at the biggest and the smallest first, because you either have to have 4 or use up one of your halves to make it a 2, or have 1 or use up one of your halves to make it half. And so that can help us approach this a little bit more systematically, but it looks like our approach worked out quite well because the answer is in fact C. So great work. Oh, fun geometry. The diagram shows 3 large circles of equal radius and 4 small circles of equal radius, where the centers of all circles and all points of contact lie on the same straight line. The radius of each small circle is 1. What is the radius of the shaded area?
The
Oh
radius
my
of the shaded area? The
What is the
shaded area. Just the shaded
Yeah,
area, yes.
true, yeah.
Yes.
I think the radius of the shaded area is like about 2 or so. I don't know, depends on how you calculate it.
I don't know.
Okay.
Not sure how you would measure that.
I don't know either. I think that we can view this entirely as combinations of 1/2. Oh, that's a highlighter. That's not what I want. I just wanted to metaphorically highlight the fact that we can view the shaded area as sum or difference of half of our small circle and 1/6 of the large circle and like this little bit of the large circle corresponding to 1/6 of the angle. You can't see the shaded area. Well, that's not ideal now, is it? So the shaded areas that we have here are right here and right here. And where else are they? All right. Okay. Here, yeah, and there. And if you look at Kieran's screen, he also has them a bit neater than I do. Kieran, you want to say something so I can see your screen?
Oh yeah, so I was starting off on something I noticed. So shaded, then the top one here, then the bottom, and then the top over here. And so what I was doing is like, there's kind of some symmetry in this picture. Like this is a really cool picture. I think because it's symmetric. So all 4 of these yellow regions. So that's just something I noticed.
And we also have rotational symmetry in our diagram, which means that we can make this a little bit easier on ourselves and just look at this region with this region and then double it. If you rearrange them, they make one big circle. Oh, really?
I'm not sure if it's going to be exact. I'm not sure if it's going to be exactly a circle, but I think if you rearrange
it's one circle minus the 2 circles, because you see on your diagram how you have that the 2 yellow ones are flipped over the horizontal axis, right? So that means that on the bottom, what we basically have on one side is this, just all of this. Like, sure, there's a line here, but we basically just have this. Yeah, so that's what? 2 squared pi minus 2 times 1 squared pi, 2 pi b.
Yeah, and kind of as another way of illustrating is that since all these yellow regions are the same right here, as I mentioned, you can put this shaded region. I'm just gonna put that one right over here. So I'm gonna move it up here. Change the area, right? Because it's the same area here, so it's gonna be the same here. And so now we have a yellow region here, here, and here. And now what I'm gonna do is I'm gonna take this region and kind of reflect it over onto this. And what I'm left with is these 4 regions. And so I can kind of cut off this half of the picture right here because this is where all my regions are left. And so what this is the area of the full circle minus the 2 little circles. And that's exactly what I did.
Yeah. And got us the right answer too, which is amazing.
Great. All right, let's move on to, I don't know what problem this is, but 14. Okay. Eva puts 2022 tiles in a long line. Then Adam removes next. What is that? Bieta? beta, I don't know, removes every fifth tile that remains. Every fourth tile. Finally, Doris removes all the remaining tiles. How many remaining tiles? How many tiles does Doris remove? Okay, there's a better way than listing out all the tiles and then actually doing this. So let's think what we can do here. So first, when Adam removes every sixth tile, if we can imagine, if we have like a row of the tiles, let's say I numbered them from 1 to 2020. So 1, 2, 3. This goes all the way up to 2020, 2022. And so at the start, I remove the sixth tile. So I remove number 6, and then 12, then I remove number 18, and then number 24. And you can see what we're doing here is since we're removing every sixth tile, what's going on is I'm just removing all the multiples. So what is the last tile that I removed? We just want to figure out what our first tile was and then what the last one I did, because then I can figure out the total number of tiles since these are all multiple of 6. And so 2022 is actually a multiple of 6 because it's clearly even. And then since the sum of the digits is even, and then since the sum of the digits is divisible by 3, then 2022. So 2022 is actually divisible by 6. And when we do 2022 divided by 6, what is, let's see, is 337. I'm doing the division because I don't trust myself. So 2022 divided by 12, no, 22, 3, 8, 3, 18, 42, 7. Yeah, so 337. What's going to happen here is I'm going to have 6 times 1, 6 times 2, 6 times 1, 6 times 2, 6 times 3, all the way up to 6 times 3 tiles that I removed. And so what I'm left with is 2022 tiles, 337 that I removed. And so 2022 minus 337 is 1685.
Seems
Yeah.
reasonable.
All right. Yeah, so I've got 1685 tiles left. Okay, I'm gonna make a new sheet here because lots of stuff on this screen. Okay, say 5 tiles again. And these ones are gonna be like assorted numbers. It's gonna start off 1, 2, 3, 4, 5, and then it's gonna go to 7. So what I'm going to do now is just erase all the numbers that are on the tiles and then renumber them, because it doesn't really matter what tiles Adam has right now. It just matters what I have now. So I've got 1685 tiles, as I mentioned. And so I'm just going to number these as 1, 2, 3, all the way up. 1, 2, 3, all the way up. And so what Beta was doing is she was removing one in every 5 of these. So she's going to remove the 5th tile, the 10th tile, the 15th tile, etc., all the way up to the 685th tile or whatever. And so she's going to remove 1685 divided by 5 of the tiles. And this is, I'll do the division out because I can't do it in my head. So I get a 3 up here, 18, 3.
Well,
oh, this looks like 330.
Do the division out because remember, if we have 6 times 337 and subtract 337, that's 5 times 337. And if we divide 5 times 337 by 5, I guess we'd get 337, wouldn't we?
Yeah, we would. And so what we're going to be left with actually is the 337 times 5. And then we're removing 337 again. And what is with 337 times 4. And so 7 times 4, we're just going to do the same thing again. And we're going to be left with 337 times 3. And so that's what's going to happen. I forget what the C name was. We're going to get 337 times 3 tiles remaining. 3 tiles remaining. And so that's what the answer would be, because that's how many are left when Doris goes, and then Doris just removes them. So 1, 0, 1.
Yeah. That is definitely a great solution. I think I saw a couple of people in chat suggesting that we could do it a little bit easier like this, where if we notice that since 2022 is divisible by 6, we can actually just use fractions. So 5/6 times 4/5 times 3/4, and then timesing 2022 by 3/6 is decently easy because 2022, divide all those by 2, 1011.
Yeah, that's what I did.
Yes, the other one most certainly works, although I am glad that we didn't have to bash out all of those other divisions just to get 337.
Yeah, just to get 337 every time.
Hopefully we would have noticed the pattern eventually. And in the meantime, let's go see if there's a pattern defined here. Because we have a rabbit and a hedgehog that have a race around a 550 meter long circular track, and they both ran at constant speeds. The rabbit speed is 10 meters per second, the hedgehog speed is 1 meter per second. They start at the same time and they run in opposite directions. When they meet, the hedgehog turned around and ran after the rabbit. How long after the rabbit did the hedgehog finish? Okay, so to get ourselves a quick diagram of what is going on, we'll start with, of course, a beautiful circle. Absolutely gorgeous, so circular, stunning, we love it.
I've got a pretty good circle.
How did you cheat that circle? I do not believe you drew that.
I did not actually draw secret techniques, so.
Tisk. Okay. Well, anyhow, we're starting here. They're running opposite speeds. Okay, so we have our hedgehog going this way and our rabbit going this way, much faster. And so eventually they meet, and then the hedgehog doubles back. So where do they meet? Well, the rabbit runs 10 meters per second and the hedgehog at 1 meter per second. So they'll meet at a ratio of 1 to 10, meaning that this distance right here is 1/11 of 550. So that is what? That should be 50.
Yeah.
Okay, so 50 meters from here, the rabbit keeps running, the hedgehog doubles back. And we want to know how long after the rabbit did the hedgehog finish. So it takes the rabbit 5 seconds. You guys can't see that, can you? Okay. Rabbit, 5 seconds to run the 50 meters. And our hedgehog friend is going to take the full 50 seconds to run those 50 meters. Subtract the 2, A. Yeah, which was correct. Oh, and I saw someone asking how to get a star in here. And so the answer to that is that we have some moderators working here to moderate the chat, which means that if you say something bad, it won't show up. But if you say something great, then it will get a star. And stars have a bit of use, but mostly they're just there for bragging rights. Looks like you got a moderator saying hi. Love to see it.
All right, well, let's move on to the next question now. Number 20. We're shown the diagram. Oh, so we do have a diagram on this one. That's weird. All right, she takes them off one at a time. How many different ways can she do this? Okay, this seems deceptively simple. Deceptively simple. Or actually, I'm gonna letter the rings. So let's say this one's A. Let's say this one's A, and then the top one's B, and then C, then D. Oh, but C is in the middle here. So this one's here. So this one's C. This one is E. So that I don't have to say like the dark gray or the medium dark gray or dark gray or something like that. So these letters are going to give me a way of like what's going on a little bit better. Okay, so first of all, when she removes the rings, like if you've ever tried to remove a ring in your life, you have to remove the top one first, right? You can't like summon the bottom one and like bring it to the top. That's not how it works, right? So B, C, D in that order. So no matter what, we're gonna have B, C, D in that order. So we can never have D or B or C before B. Or D before C, I guess, for completeness. Yes, for completeness. And so is at any point in which like we're removing the BCD rings, we can stick an A or an E in the middle there. Because if you're removing B, if let's say you B first and then you're like, oh, actually I want to take off A now. Then you can just take A then, right? And you're still going to have BCD in that order. It's not going to affect anything. And so what we have to do here is first we have to insert A into any of the spots of the two rings. So either we can do A first, we can do A fourth. And so that's four options for A. So we've got four choices for where we can put A. And then the same thing applies for E, right? Since E is also on its own. And so once we put A somewhere, it doesn't actually matter. Then we have to put E in this sequence. And E can go in any of these 5 positions. Because now that we have A, it's actually a 4-letter long sequence instead of a long sequence. And so choices to go, right? It can go at the start or end or in the middle. And so E has 5 choices. And what we're going to do is just 4 times 5, because 4B, 4 times 5, and that gives me 20.
Yeah. I think that we do have a couple of people suggesting another way to do it in chat real quick, which I do want to go over. And there's a couple of ways to think about this. So we can either keep the A, B, C, D, E numbering system, but we can do, we can divide 5 factorial, which is the number of ways to arrange all 5 of our rings if they weren't stacked, by 3 factorial, because that's how many arrangements of BCD there are. So that's our factor of overcounting. Or another way to conceptualize this to do the same mathematics is to think of it as A, B, 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 C, and to rearrange those. And then you know that those B, 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 you just take the topmost ring off of your finger. And that will, of course, give us the same answer as Kieran, thankfully.
That's a cool way to think about it, with the A, B, 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 C. I like it. C. I like
5 times 4, yes. Yeah, that is funny, yes. We've got some real mathematicians in chat today. Maybe we've got some pirates in chat too, because this question says that a group of pirates divide 200 gold coins and 600 silver coins between them. Each officer received 5 gold and 10 silver. Each sailor. Oh my goodness. That is a lot. Okay. So let's write this as algebra. So let's write how many gold coins there are. 200 gold coins, or 5 times the number of officers plus 3 times the number of sailors plus 1 times the number of cabin boys. And 600 for silver is 10 times the number of officers plus 8 times the number of sailors plus 6 times the number of cabin boys. And then we need officers plus sailors plus cabin boys. We want to find out what that is. This would be a pain to solve. This definitely seems like a bit of a pain to solve. So that's what the problem number of the last one was, 20. This one is number 23. Okay. How do you want to do this? Because again, remember, we aren't going to be able to solve for each variable individually. We need to be able to solve for their sum. But I don't think, would that work? No, not as well as I'd want it to. So I was thinking we could try to double our Oh, just subtract the first from the second. You're smart, right? Because they all differ by 5.
Yeah.
Yes,
Yeah.
okay. So yeah, what does that give us? 5 times O plus S plus C, because that's 10 minus 5, 8 minus 3, and 6 minus 1, is 600 minus 200, which is 400. Oh, and let me move this up a little bit for you guys to see. And then, of course, 400 minus 5 is 80.
400 divided by that.
Yes, that.
Yes. Yes.
Helps to say the right things.
Megan, except I use F instead of O because I don't like using O variable because it looks like a 0. Because it
You're
looks
not
like a
wrong.
0.
I would not use O for anything that's going to require a lot of calculation. But if you see something like this with this limited amount of information, you can assume that it's just one particular shortcut that you need to do, and then it just all falls into place. And so if you can keep your mind straight for that long, then you are A-okay. If you can't, then definitely, yeah, just do what Kieran did. Or to play it safe.
Okay, number 26. A grocer has 12 different integer weights of 12 kilograms. She splits them into 3 groups of 4 weights each. So the total weight of the first group is 41, and of the second is 26. What of the following weights is in the same group as the weight of 9 kilograms? Okay, so first of all, they only gave us 2 pictures here, which means we have to figure out what the third picture is. And how I'm going to do that is I'm going to look at what is the total mass of all together. And so that's going to be 1 plus 2 plus 3 plus 4, 3 plus 4, all the way up to plus 12. Formula, like this is equal to 12 times 13 over 2. But instead of doing that, I'll just like for how that works, because if you haven't seen it, you will not know what I'm talking about. So what we're going to do here is we're just going to call this sum. And so we have S over here, and then in the second row, I flipped S around. So I put 12 at the start, 11 all the way down to 1. And this is the same thing as S, right? Because if we sum thing is we just summed it normally. And so what we can do here is add these 2 equations together. And what we get is 13 in the first column, then 13 in the second column, 13 all the way down, right? And this is equal to twice S, right? Because we have S plus S on this side. And we actually have 12 13s here because we had 12 columns start. So 12 times 13 is equal to 2S. And then if we divide both sides by 2, we get 6 times 13 is S. And so 6 times 13 is 78. So we just plug in that 78 up here, and we get our sum is 78. Okay. So this tells us that the total is 78. The total weights of everything combined. And so I see Richard has exactly what I'm about to say. So since this one is 41 and this one's 41 and this one's 26, these two combine to 67, 78 in total. The only way we can do that is if the last thing we can do that is if I'll draw my last box here comes to 11. Okay. 11. 11 seems like a really small number. Different integer weights, they have to be different, right? So I can't have like 1117 or 1118 or something, right? So I have to do something like 1, 2, 3, 4. Like that's the lowest I can possibly get. And so 11 is kind of small. I tried out 1, 2. So 1, 2, 3, 4 gives me 10. And so the only way I'm going to get 11 is if I increase one of them by 1. So if I have the weights 1, 2, 3, 4, and I want to increase only one of them, the only way I can do that so that there's no 2 of the same thing is if I increase this 4 to 5, right? Because if I increase this 2 to 3 or something, I get 1, 3, 3, 4, and that doesn't work. So I have to have 1, 2, 3, 5 in this group. So that's a really good start. Okay, so now I'm going to look at this one, because that's the next smallest thing. So worst case scenario, the lowest I can possibly get for a sum of 26, is having the weights 4, Okay, well, 4, 6, 7, 8, that sums to 25. Oh, 25, okay. So this goes to 25. And that's really close to 20, and that's really close to 26. So we have the same principle as what we have to do is increase one of these weights by exactly one. And so if we increase the 4 by 1, that would give us, but we already used the 5 over here, so that doesn't work. If we increase the 6 by 1, that gives us that. If I increase the 7 by 1, that gives me 2 8s, and we can't do that. So I have to increase the 8 by 1. And so what that gives me, in this group, I've got 4, 6, 7, 9. And what does the question say? Which of the following weights is in the same group as the weight of 9 kilograms? Okay, so the answer is 1 of 4, 6, or 7. And the only one I see in the answer choice is 7, so C.
Yes, that is a great way of thinking about it. Gives us the right answer too. I want to draw attention really quick to a comment I saw a little bit ago that was suggesting we could use our diagram or the drawing provided to maybe guess it. And I think that what's important to notice here is that you can never assume a diagram to be drawn to scale unless it says it is. And while it is possible that this one could be drawn to scale, as we notice from our answer, these don't quite line up with our actual values that we found in each of them.
Yeah.
So that could have very easily gotten us stuck somewhere. Plus, given the nature of our answer choices, 3, 5, 7, 8, and 10, those all, they're not right next to each other, aside from 7 and 8, of course, but they're not super far apart either. So since there's only one correct answer, unfortunately here, we do have to do that. Yeah, Math Kangaroo is not to scale. That is, yeah. Of course, not to scale doesn't mean useless. They can still be a great jumping off point, but I don't know if you guys have ever seen, I'll show you guys at the end if you guys are interested. There's a really fun geometry paradox that involves the person drawing the diagram just not doing it to scale at all. But yes, in the meantime, here's a diagram that may or may not be drawn to scale with 5 circles of centers A, B, C, D, and E arranged as shown in the diagram. Line segments are drawn to join the centers, and you want to find which point is the center of the circle of the largest radius. Diagram is not to scale. Oh, well, that answers our original question. If our diagram isn't to scale, then let's go and find the answer. And the first thing I see so we can write these out as 5 equations, where basically I'm going to call the radius of the center of circle big A, I'm just going to call that little a. So A plus B is the segment AB, and that is 16. And then of course B plus C is 14, C plus D is 17, D plus E is 13, A plus E is 14. And yes, this is a law of symmetry, so yes, we want to try to add these up. That is a great idea. So 2 times A plus B plus C plus D plus E is, well, okay, that's 30, that's also 30. 30 plus 30 is 60, 74. Okay, so A plus B plus C plus D plus E is 74 over 2, or 37. So what do we do now? Well, remember back here, we have A plus B and C plus D. So if we subtract those two from our total, then we'll get E. So, for example, E is going to be equal to 37 minus 16 minus 17, or 4. And similarly, D will be equal to 9. C is going to be equal to
So once
Well,
we
we
have
can
a
just
few
get there somewhere.
values,
Yeah, from the first equation, right? We can just keep plugging it
yeah,
in.
from so like it kind
Yeah.
of starts a chain once you figure out what the value of E is, right? You can plug this in and you find D. Plug that in, you find C, then D. Then...
Yeah. Yeah, no, I was going to do it the long way around, but yes, that is a lot quicker. Okay, yeah. So once we know this, we just have to see which of these is the biggest. That's the 2-digit number. So our answer is A, which is definitely not what this diagram shows.
Does A look like the smallest here?
I would say
Yeah,
so, yeah.
Yeah, A or E is definitely the smallest.
Yes. Well, looks like our answer is AA. I've been told that we have the diagram that did not load earlier. So let me see if I can pull that up now. Okay. It's going to be slightly scuffed, but okay. Woo!
Oh, okay. Hold on,
And
let me pull the problem back up on my screen.
yes.
Ah, there we go. Okay. And let me erase all my previous work because it seemed to be not applicable with the diagram.
Yes, so now that we have this, this becomes a lot more doable, and I get what you guys were saying earlier. So we want to find what could be x plus 1 and y plus 1, and as it turns out, 77 is, what's the word, is it semi-prime?
Yeah,
Yes,
semi-prime.
semi-prime.
Or,
it only has
yeah.
two prime factors, 7
Yeah.
and 11, which means our only options for 7 plus 1 and y plus 1 are, well, one of them 7 and the other is 11. So x and y are 6 and 10. Since we know that x is greater than y, then it's 10, like you guys are saying now and were before. Yes, great job. This diagram definitely makes it easier.
Yeah. When I read this at the start, I didn't understand it at all, but the diagram helps out.
Definitely, yes. Okay. Well, I believe that is the last question that we have for today. I want to show you guys that fun paradox real quick. So basically, the idea behind it, if I can do this correctly, is, let me turn off the problems because this is not a Math Kangaroo problem. So, I have a triangle. Actually, no, let me make it a little bit more scaling. Love you a scaling triangle. Okay, I have a triangle and it has an angle bisector and 2 medians. Or is it 3 medians? Shoot, I cannot remember this. Have you seen this before, Kieran?
I have not. I am very interested in this though. I'm sorry that I can't help. I'm sorry that I can't help you out with it because I wish I had seen it before.
Yeah. Shoot, let me remember exactly what CVNs you draw.
Let's see. I do remember seeing something with like if you draw diagrams badly, like every triangle is equilateral or something. I'm not sure if that's related to what you were talking about.
It wasn't equilateral. This proof is for. This proof is for isosceles.
Oh, okay.
So I can't find it online, which is mildly not ideal. Yes. One angle bisector and 2 medians. I think that is correct. Yeah. And oh goodness, why do I not? This is a fun brain teaser. No. Yeah, no, it's fun. This might be it. Here we go. Okay. Found someone else doing it. Okay. So, oh, okay, right. Misdrew this. Okay. So we have our angle bisector. I don't think medians are actually in this. I think I got my different steepings mixed up. Good God. Okay. Angle bisector. It's beautiful. And we draw the perpendicular bisector of our triangle here too. I'm bad at drawing, so please give me some allowances. And we then connect these up like this, and then we drop the perpendiculars of this out to here. Now, one thing that you will notice quickly is that since these two triangles share an angle and a hypotenuse, then these are equal. And so these are equal. And so we also have, what else do we have? Right, down here, we have that, BQR, so that's this triangle is congruent to this triangle because they have an equal leg. Because again, remember, their legs are the hypotenuse of these two smaller triangles. So these are equal. So that means these are also equal. So now we've got an isosceles triangle, because if you add two equal things, you get something that's equal.
Yeah. So this is actually really interesting.
Yes. They are equal.
Because if you look at this picture, like it's in the entire world at drawing things, so it doesn't look that accurate. But the thing is, there is a degree of accuracy, and the reason this doesn't work, like this, it seems work, like this, it seems like it on the surface, like I'm like, wait, what's wrong? Like clearly, not every triangle is isosceles. You've all seen a non-isosceles triangle in your life. So what? And the issue is a tiny thing, which is like the perpendicular bisector here. It has to be, it's actually correctly on the other side of the angle bisector. So this angle bisector point, but the perpendicular bisector, since this side is smaller than this side, it's actually should be on the opposite side. And when it's on the opposite side, they're going to meet down here because we have to extend both of the lines and they're going to meet somewhere like right here. And that's the reason it doesn't work, because if they intersect in the triangle, we get this super weird conclusion. But if we put it on the other side, then they meet like somewhere down here, and then we're just going to get something, that like one, like, I don't know, and something we'd expect to happen.
Yeah, so that is absolutely correct. But actually, something weird happens even after we do that. Okay, give me a second to finish drawing the new diagram, because
Is there like a level 2 to this or something?
there is a level 2 to this. That is exactly correct. And the level 2 to this is that you are correct. They do actually end up meeting. I'm bad at geometry, so don't judge my diagrams. They end up meeting around like right here. But one thing that you might notice, oh shoot, I did not mean to get rid of that one, is that I did not mean to draw that as a curve. Okay, let's just draw this properly. Okay, there we go. So we've got ourselves a beautiful diagram where they meet on the outside as they should have. And we've once again taken it upon ourselves to drop some perpendiculars down here. So again, ignore the fact that I am not the best with this whiteboard, and we still have our perpendiculars. Remember, this is congruent to this, so we now have this triangle right here congruent to this triangle. So let's just denote these congruents real quick. Again, that's just because of the perpendicular bisector. But you'll notice that, shoot, what is going on here?
So I think the pink triangles with like the 3 hash marks on it, those two are going to be congruent, right? Because that point at the bottom on your picture is with those sides. And so that would tell you that those tiny pink lengths on both sides are the same. Lengths on both sides are the same.
Yes. Yeah. Like I said, geometry is not my strong suit, which is why I can't even show you the issue of this already. Believe me, there is an issue, because if we do what Kieran said, if we end up subtracting these bits, we get another isosceles triangle, which might not be correct, considering that we just grabbed ourselves a random scalene triangle. So, can anyone figure out what the issue is now?
So kind of adding on to what Megan was saying, in her diagram, this thing is like the long pink segment, and then this thing was the same, and this one, those two are the same. And so by the Pythagorean theorem, these two yellow things are the same. And so and those yellow things in her picture were like the side lengths of the original triangle. And then we added on those two little pink things, and those are the same. So our sides of the triangle are the same.
Yeah. Basically, can you find something wrong with the diagrams that me and Kieran have up? Because our diagrams currently say that all triangles are isosceles.
Well, I think my diagram is actually slightly different than yours.
Yes.
Kind of hard to see with my background. But
yes,
these blue segments right here, this one and this one, they actually hit the inside of the triangle instead of Megan's, which hit the outside of the triangle. And when I hit the triangle, and when they hit the triangle, that's where the issues. Would it?
Yeah. You know, it depends on the exact angle of this one right here, and also the length of this bottom line. The drawing has to be accurate. Well, what's wrong with her diagram then, Michael? I think it's pretty accurate. I drew exactly what I wanted to draw. It is
I'm
accurate?
trying to see what I'm missing there.
Yeah, well, okay. It is 6 p.m. if you're in the correct time zone. For the rest of you, it is still the end of our officially scheduled thing. I'll give you guys a minute more to work on this question, and then I will reveal the answer. I'll give you a hint. The diagram is not accurate, because if it was, all triangles would be isosceles. Yes, hope you guys had fun. Oh, Richard, do you have an idea? Yes, thank you guys for coming. It was a lot of fun. One in, one out. That is actually exactly correct. So, for
Oh,
non-isosceles triangles, one of these is inside and the other one is outside. And of course, if you take two equal things, add x to one of them and subtract x from the other one, you're not going to get the same thing.
yeah.
So yeah, that is the issue there. Keen eye.
Oh, that's clever. Okay. Because when I
Yeah.
was drawing it, I originally thought the issue was going to be they're both going to be inside. But this both inside thing actually is the issue we had last time. So I drew this first one and it made sense when I drew it inside. But the second one I tried to had to like make it second one I tried to had to like make it a stretch to go inside. And now I see why that right angle on this side is
Yeah.
because it actually shouldn't be a right angle.
Yeah. Yes. It's a pretty fun paradox. It's a great way to trick your friends if you want. It is not. No, it's very fun. Excuse
Yeah.
you.
Yeah,
Yes.
I think this is really interesting because even though like Megan and I have been doing geometry, but I didn't like I was like, what is wrong with this? Something has to be wrong with this, but I discard you.
Yeah, Nathan, if you search proof all triangles are isosceles, you'll see it. Garuds, I do not believe there is a level 3.
This was actually the one I saw. Um, but they just extended it to equilateral triangles as well because they said if this thing is always equal to this thing, then we can just do like rotate our
Yeah.
heads and then do on these two. And so this thing is equal to this thing, which is equal to this thing. And so it has to be equilateral. So mine was the same thing. I just didn't recognize it immediately.
3 Blue 1 Brown has it. 3 Blue 1 Brown is amazing. Yes, I heard this the last time was a few months ago from my math club coach. So a little bit rusty. It was just a fun end of year thing. Question, Richard? Yes. And while we're waiting for Richard, once again, thank you guys for coming. I hope you guys had fun. Hope you learned something, and hope to see you again soon. Yes, goodbye. Thank you guys all for showing up. It was a lot of fun here. I see we've got a first person with fake stars.
Fake stars? How do you do fake stars? I've never seen that. Oh, I see it.
People change their names to put stars at the end, so that way it looks like they've been given stars when they actually haven't.
That's clever. That's very interesting. I've never seen anyone
clever.
do that.
It's bad. Don't encourage them.
It's pretty kind of convincing. I could notice it, but it's a good idea.
It's really obvious on our end, just to be clear here, and it's really obvious if you ever do get a star. Yeah, bye Richard. Bye Aaron, bye Remy. Bye, Joy. I think they probably already left, but yes. Fare thee well to all of y'all wonderful human beings. Thank you for spending this Friday evening or night or wherever you are living the time of that. Thank you for being here. Some is from Vietnam. I don't know what time it is in Vietnam, but I'm pretty sure it's not evening.
Should be the morning there, right?
Hey, can I say something funny about the diagram you guys were showing at the end?
Yeah.
Yeah, sure.
If the triangle really was isosceles, the angle bisector and the perpendicular bisector would overlap.
Yeah, so
and you would even get a point.
Yeah, because
That's
what's
pretty
happening
interesting.
there is that yeah. I think there might have been something about like 0, and so that's why oh yeah, because remember how we end up saying that you take two equal things and you add x to one of them and subtract x from another? So that x is like the little schmidgen, like here
this thing, I think.
and here. But if that's 0, then if you take two equal things, add 0 to one, subtract 0 from another, you get equal things. So that's how you get some triangles that are isosceles.
Yeah, exactly.
just find it interesting how like the proof that all triangles are equilateral, not equilateral, isosceles, wouldn't actually work on an isosceles triangle.
No, it does work.
No, it
Kind of.
wouldn't, because like there wouldn't be an intersection between the perpendicular bisector and the angle bisector because they'd be the same line.
It would act
They
well,
would
yeah, they'd be the
kind.
same line.
Yeah.
That's interesting. Yeah. I
Yeah.
think we
I mean,
just call it this point down here.
as you take the limit towards being more
Yeah.
isosceles, the thing approaches 0. But this isn't a calculus live solve, so I'm not trying to get into that. Is that calculus or pre-calculus analysis? I never know.
Kind of. I guess it counts as calculus. Because like you're getting closer and closer to something, and this is getting closer and closer to this, whatever.
Yeah,
Like, I don't know.
geometric calculus, the new field of study. Oh yeah, I get to write my English paper on geometric probability, and I am so happy about it. It is going to be...
That's so great.
Yeah.
Your English class is so much better than mine.
Bro, my English class is literally a class on how to write STEM papers in a way that doesn't bore people out of their minds.
That sounds like a great class.
It honestly is. It's our largest senior
yeah.
English class. You have 3 options. You can go into writing STEM to not bore people out of their minds, analyzing like stan culture on Twitter under an English analysis lens, or doing even more literature analysis. Those are
yeah,
your
I
3
think I know
options.
which one I'd go with.
Yeah. Like we've got a couple of the politics kids. Yeah, 1 hour, this is over. We've got a couple of politics kids in there because good politics is based on evidence, and like, you know, like they just want the like political science, that sort of stuff.
Oh, interesting.
But yeah, it is.
Yeah, that sounds fun.
Yeah, no, it's great, and we get to read like some of the worst articles ever written too. Like we saw this one article, 2 pages long. The first page: being a couch potato is actually good. It is critical for the survival of our species that you stop doing CrossFit. The second page: so, some scientists have studied fossils of jellyfish and some current jellyfish and have found that the jellyfish that currently live have a lower basal metabolic rate, which means that they consume energy a little bit slower. So if you're looking at jellyfish, all other things equal, having a slower metabolism is good. And then, like, the very end, the scientist is quoted as saying, like, I'm worried some people might try to take my discovery out of context and say that it means something that it really doesn't. This is really just initial research.
What context is there for this?
The context is that they studied, like, jellyfish metabolic rates, and the extrapolation was humans should be a couch potato. I'm not joking here. That was legitimately something that we read.
That sounds like a really interesting class.
It's a great class, yeah.
I wish my classes were that interesting.
You know, we're in the same room. Bye, Richard. I'm pretty sure you said bye like a dozen times, but I'm glad that we've been so entertaining that none of those have actually convinced you to leave. The classroom we're in is the history classroom of our school, and they have like a bunch of history memes up on the wall, like printed out, taped to the wall. Like there's one of like this painting of this king dude, and it's just like he's just like flexing his calves, and it's just about how this guy always flexes his calves. Or there's this random one about, what's it about? It's like just like, you know, the meme. Let me be hip and cool for a second. You young children, you know the meme of the car that is swerving quickly to one side on the highway under a highway sign that you can put stuff on. Meme culture, I know exactly what that is. But there's like just like a straight up meme about how historical civilizations chose to torture people. It's just there. As it should be. There's a sloth on a towel in our math classroom.
A what? On a what?
A
A
sloth.
sloth on a towel?
Yeah, and it's hung up.
Why?
Because our teachers like to decorate. One of our teachers is named Ripley. He has a movie poster on his wall that just says like the nefarious Mr. Ripley or something. Or sorry, Dr. Ripley.
It's not a live sloth, right? It's not like his
no,
pet.
No. Oh my goodness,
Okay.
no. It's a picture of a sloth.
Okay.
On a
I was
towel.
confused and concerned for a second. Like, what could you possibly do with a sloth on a towel in a math classroom?
You can say hi and use it for decoration.
That's true. It's a fair point.
Oh yeah, this reminds me, like last year, my English class, we were like looking at propaganda or something, and then so like my teacher pulls up like a video of Trump calling Joe Biden a Trojan horse, and then we ended up naming like one of the potted plants in her room Joe Biden the Trojan horse. It was a interesting year.
Sounds like a great year. You know, I remember we did a section of our history, like it was modern US history. But we did a section on like a mini unit on the 1619 project curriculum, and we got to look at that, look at critiques of it, like advocacy for it. It was pretty cool. That's the revised curriculum of, like, it's the proposed alternate history curriculum that focuses on slave treatment, for any of you guys who don't know.
I think
Oh.
my teacher might have also gone over that last year as well.
Yeah. You know, it's a lot of fun at my school. Good times all around.
My school is really scuffed. Like they didn't let seniors get their ID cards because they were afraid that the seniors would do something inappropriate on them. There's like there's literally a photographer there taking the photo. How do you do something inappropriate?
Just like secret.
Yeah,
Like
there's like
literally no one knows except for you.
yeah, also the teachers take the photos at the same time as the senior students. So like every several students, there's a teacher there as well. So like how does admin expect us to do anything inappropriate?
Oh my goodness. Yeah. The most inappropriate